Welcome, everybody. This is the final for Architecture 271, Construction Documents for a Multi-Unit. And just like everything in our program, it has two purposes. It will also be a legacy, so the community and the new students can learn very quickly how to design a multi-unit proposal on a 150 by 50 traditional lot. We're entering a competition called Low-Rise Housing, organized by Christopher Hawthorne and Mayor's Garcetti Innovation and Sustainability Team. We are very proud, and we're going to take you step by step, not only about the command of the tool, but also the considerations, legal, structurally, architecturally, of each of the stages. Enjoy. We'll begin with an introduction. Diana Vargas.
Good morning. So I'm going to go ahead and share my screen. Give me a second. I had it open. So I'm going to be talking about the four main things, which is like the crisis, inspirations, the multifamily, and our solutions. So the main reason that drove us to design this multi-unit is the fact that we are currently in a very large crisis in LA, that it seems like nothing is being done. And I don't know if many of you guys have gone around to see, but LA is full of homeless people, which is very sad and unfortunate. And so Los Angeles City has the largest home population at 59,000. Los Angeles County homeless population has increased by 12% during the past year due to the shortage of affordable housing. Skid Row district ranks among the greatest concentration of homelessness in the U.S., currently at 300,000. And the worsening situation is the rising cost of housing and the wage stagnation. And so Homeless Service Authority points out that the main reason for the homelessness is due to the high rents and shortage of affordable housing, the stagnant wages, and the systemic racism that affects housing, healthcare, justice, and economic policies. Many tenant groups and advocates of those that are currently experiencing homelessness have said that nothing is really being done in order to protect the homelessness. So it is why we came up with this idea, because we obviously want to help those in need and those that really need a home. And these are just some stats showing where people that are homeless are sleeping in. Most of them are obviously sleeping out in the open. Emergency shelters, even though there's obviously not a lot. Motorhomes, vans, tents, and cars. And the LA County homeless population jump, like it has increased drastically. And so I'm gonna go ahead and talk about our inspirations, what drove us to come up with the design that we came up with. And the first one is the Ames House Case Study House number 8. So Case Study 8 is one of the roughly 24 homes built as part of the Case Study House program. Architect is Ray and Charles Ames, and the style is the mid-20th century modern, and the location is in Pacific Palisades, Los Angeles, California. The houses were built and furnished using materials and techniques derived from experiences of the Second World War. And in addition, I believe that all of the World War, and I feel like that's something that relates to us, because in a way, a lot of the people that are homeless, like they want a home, and we should just help them as equally, because I feel like everyone is equal and everyone deserves to have a nice home. Like Professor Oliva has said, like just because it's cheap doesn't mean that it doesn't have to be designed well. We have the ability to do that, and I feel like this is a great example. So the architecture of the Ames House property contains 2 adjacent buildings, 2-story house, and a matching studio that is separated by a small studio. Both buildings are simple boxes, and they reflect industrial design and materials and graphic monochromatic sensibility. They are built of steel frames clad in fixed panels made of plaster, wood, and glass. And there's pops of white and bright primary colors among the beige, black, and gray panels. And they lend a Mondrian style touch to the facades. And the design is modular. So I'm going to go ahead and talk about the 5 points of architecture. And so Le Corbusier, he was a Swiss-born architect, and he belonged to the first generation of the International School of Architect. He was born October 6, 1887, and he was known as the most important architect in the 20th century. He built with steel and reinforced concrete, also worked with element geometric forms. And in 1914 to 1915, he actually developed his first major theoretical work, the Don Eno House, a reinforced concrete frame. And so what are the 5 points of architect? So the five points of architecture is number one, raise the building on pilotis, freeing the walls of their structural function. Number two, the walls freed of their structural role of free plan. And number three, the facade should be designed freely. Number four is the horizontal ribbon window, which enables a free facade and should evenly lighten up the rooms. And number five, the roof should be flat in order to have a roof garden. And so in addition, this is a great example. The Via Savoy is a true demonstration of the 5 points of architecture because it basically has a pilates, the window, the roof, the garden, the roof garden. And so basically this house was completed in 1931. Its main living spaces are raised off the ground. Lower level is dedicated to the maintenance and service programming of the house and is a machine for living in. And let me go ahead. So another concept that we learned during the class was biophilia, and I feel like this is the most important one that we learned. And so what is biophilia? It is the connection between a building and nature. Biophilic design helps reduce stress, enhance creativity and clarity. It is a relationship that is essential for us to sustain our health, well-being. And the economics of biophilia estimates that providing American hospital patients with the views of nature can save up to 93 million per year. And it is a combination of science, design, and touch. And so there's many examples of biophilia, and some of these designs were incorporated into our multi-unit. And the first one can be direct physical ephemeral presence of nature, a certain space or location, plants, flower beds, butterfly gardens, water features such as fountains and aquariums, green walls, and vegetable roofs. And so the visual connection with nature, it's basically a view to elements of nature, system, and natural processes. Spaces have a view of nature, natural system, or living elements. It helps reduce stress, increase positivity, emotional function, improve concentration, and expedited healing rates. And it obviously will not bore people with the view that they're having. And so our multi-unit. So this is where we all kind of gather, we put everything that we learned throughout the semester and we created this. And so our multi-unit is either 3-4 complexes or 4 on a side of 150 feet by 50. Each unit is 30 feet by 25. Each complex has 3 floors. First floor consists of an area to exercise, entertainment. Second floor consists of the kitchen, half a bathroom, laundry, living room, and dining room. The third floor consists of 2 bedrooms, a full bathroom, and office and balcony. And the fourth floor consists of an entertainment area and a roof garden where vegetables can be grown. All of the units are connected by CMU wall that will also be a green wall. The units all have prefabricated with customized green curtain walls. And basically this image shows what we would be doing, how we would picture our multi-unit if it actually was built. For example, we can have a balcony, as you guys can see with plants, something that kind of can be like an escape room for people to get out and kind of just enjoy the nature, because we live in the city and we don't get a lot of that. And I feel like if we can bring it to our homes, like it would honestly definitely make a change. and then the open web truss, the steel columns, as you guys can see here, and the prefabricated with customized green curtain walls. And like I said, the first floor is for entertainment exercise. The second floor consists of the kitchen, bathroom, living room, laundry room, and dining room. And the third floor is 2 bedrooms, bathroom, and office. And so some of the green ideas that we came up with is having a roof garden to grow food. I think that that's super important because locally we don't really have a lot of places where we can go and get organic food, organic vegetables. Like, so having this, like, it would definitely help everyone out, and it's very sustainable. There's some water capture ideas, and then there's a balcony. Like, you guys can see this image. It can be something like that we can create, and then recycled materials. And then also this image shows something of what it would look inside when you walk by, when you're coming up the stairs or going up the elevator, like right in the center. It would look really beautiful. And it also incorporates biophilia. And then this is the green wall that we can add. And then solar energy, which obviously would help out a lot. And here are some of the students that help create this great project.
Our next is for us is that we need to consider the different types of multi-unit houses. And with you is Brooke.
Thank you, Professor. My name is Brooke, and I'll explain about earlier we discussed about the multifamily housing unit in depth based on our project. Right now, we'll see about the types of multifamily housing unit. So let me jump in explaining about what's multifamily housing unit. Multifamily housing unit at a municipal level, they also call it MDU, which is referred as multi-dwelling units. And a multifamily housing unit is a space or a multifamily house is composed of multiple separate housing units that are combined one or several buildings and a single complex. So by saying that, I'll jump into the types of the multifamily housing unit. And the next one is a duplex. Uh, a duplex is a one building divided, as you can see here on the plan, on one building divided into two uh, separate into one house, two separate uh, living units. So they have a separate entrance, and there are usually no common area inside the duplex areas. Here like they don't have a common area, but they are one, so they have their own garage, their own space arrangement, and also living areas. So one unit, we call it the we need for living. So the next one is a townhouse. A townhouse is uh, a townhouse is an individual owned unit that mimic detached home. However, it is attached to one or more townhouses. So it's similar, but it's detached and it's attached to another townhouses. So this is the first floor and the ground floor, and they're attached to one to another. Okay. Uh, Quadruplex. Is a quadruplex is a building which is basically four units inside four units within one building or one house, and it has four units. This is one of the our projects in earlier we mentioned it as uh, a literatic architecture project, and it has its own units and its own inside like the kitchen, the circulation, and it has its own unit, but at the same time it will share walls and other facility. And when we design this multifamily housing unit, we use Le Corbusier, or we inspired with the Le Corbusier, the 5 points of area, And to mention those points, the first one was the pilotis, the free plan and free facade, and strip window. So we use those. You can see on the plan, it's free, like for the circulation and other ventilation in the building system. We use those by inspired by Le Corbusier, and similar to this, we can go to the redistribution, more based on their units, classified their names. And
Thank you very much,
thank
Brooke.
you so much.
Now we're going to move with regulations and codes and variables, and how do we start with a parcel? And for that, we're going to have Daniel Ramos. Thank you, Brooke.
Okay.
Okay, so we're going to move to actually how do you start thinking about locating your building on your site. And for that, we have Edward Tonoya.
Hi, I'm Edward Tenoyan, and I'm going to be talking about the grid and also the concrete slab on the ground floor and how to demonstrate it on Revit. So the use of the grid in construction documents. The grids are a series of interlocking lines, both horizontal and vertical. They're equal distance to each other, and they're mostly used for organizational purposes. They're going to help you in terms of creating construction documents by being a guiding line, and also by providing precise measurements and forming the organizational system of the components. So drawing the grid is usually the first step in the process, and it's going to influence your entire layout in the project. As far as the construction phase goes, they're a reference for locating specific components on the site and attributing them with a location. For example, if you're trying to build a structural column, you can easily locate it by referring to the location on the grid, such as 3H. As far as design goes, and the designs that our design is based off of, the Eames House makes use of the grid, and it has been used throughout architectural history, mostly by creating a pattern of organization for the designer. The Eames House uses the grid throughout its layout and the placement of its structural members. Also, the modular design is based off of a grid formation, and it creates a system of standardization, which retains proportion and harmony throughout the structure. Le Corbusier also made use of the grid, and he stressed its importance. He also elaborated the use of the grid by adding an anthropometric dimension, which basically takes into account the human scale. As far as concrete slabs go, we're going to be adding a monolithic concrete slab, which encompasses the entire property. Concrete slabs for foundational purposes are usually 4 to 6 inches thick. They're a fast and efficient way of creating a foundation. It can be poured all at once. So the concrete slab is generally positioned on a layer of sand in order to improve drainage conditions, and it also acts as a cushion. And the ground underneath has to be at grade. It has to be a flat surface, and take into account that there's not going to be a crawl space or a basement, and it's not recommended for cold climates. And this is a detail of a concrete slab with a CMU unit that's attached. And finally, because we're putting a concrete slab over the entire property, we decided to have a pervious material as the concrete. And this is mostly for water strategy purposes. It's going to ensure that water actually penetrates the concrete and goes into the ground instead of being runoff that contaminates the ocean. And there's all sorts of new technologies that create an aggregate which is more loose, that allows water to seep through instead of infiltrating our water supply.
And now, as we have mentioned, you're not only going to learn about the concept and the knowledge of architecture and engineering, but we're going to show you how to do it on Revit.
Right. So I opened up a blank architectural template on Revit, and I'm going to start by placing the grid. So we're going to make sure that we're in the architecture tab, and under datum, we're going to select grid. Now we're going to approximate the location of our grid, and in this case, you can always edit it afterwards, but I'm going to start placing the first line in this bottom left corner where I know that it's going to start. And I'm going to start with the vertical lines first. So I'm going to click, and then I'm going to drag my mouse up. I'm going to click again. And now I'm going to press the escape key twice. I'm going to select the grid that I just created. And under modify, I'm going to select array. Next, I'm going to click on the grid again. And I'm going to drag my mouse to the right until it says 5 feet. I'm going to click. And under the entry box where it says the number 2, I'm going to type in the number of lines that I want. And in this case, it's 31. Typing that in, I'm going to press enter, and you can see that it created 31 lines. So now I'm going to do the horizontal lines. I'm going to click on the architecture tab again. I'm going to go to datum, press grid. I'm going to start in the upper right hand corner this time to drag it to the left. I'm going to click, drag, click again. I'm going to press the escape key twice. And next, I'm going to change this 32 to be an A so that there's letters on one side and that there's numbers on the other side. And that makes it easier to read the grid. So I'm going to click on the 32, type in A, press enter. And then I'm going to click on this grid, the line. I'm going to select array under modify again. I'm going to click on the line B. I'm going to drag it down 5 feet. Click again. And in this case, I'm going to type in 11 lines. I'm going to click outside of the grid. And so now we have the basic layout of the property. If we want to edit and clean it up, we can do that. I'm just going to select these lines over here. Click ungroup. And now when I select one of the grids, this little circle will pop up. I can move that and that'll clean it up. I can do the same thing to these vertical lines. Select them, click ungroup, click, circle, drag it. So now if you want the grid lines to be halftone so that they're not as cumbersome when you're drawing out the construction documents, go to visibility/graphics under the properties, click edit, go to annotation categories, scroll down until you see grids, and on the right side, check halftone, press OK. And so now I'm going to draw the model line for the entire property as well as the individual units. So under the architecture tab, under model, I'm going to select model line. I'm going to, under draw, I'm clicking on rectangle, starting in the upper left. I can also change the line style to be wide lines, which I'm going to do in this case, just to make it more visible. Clicking. And now I'm going to do the individual units, and we decided on ultimately doing a 4-plex, but in this case, I'm going to do for 3 units. And you can see how the grid makes it easier to define the measurements of each structure, which is 25 by 30. And they're going to have 15 feet in between. And it really depends on how much space you want to leave in between the units and or how close you want them to be. So I'm going to press the escape key twice. And now for the slab, which takes up the entire property, I'm going to click on structure. Under foundation, I'm clicking slab. Under draw, I'm going to click on the rectangle, and I'm going to do the same thing. Clicking, dragging, click again, and I'm going to click on the green check mark. And now, as you can see in 3D view, there's your slab. And that's it.
Professor, you're muted.
Thank you very much, Angelica. So now that we know the parcel, we know the footprint of the building, we learned that the grid helps us locate the spacing and the modularity. Now we're gonna move to number 2. So one of the things that is very exciting about our project is that we have a CMU that covers the entire, almost entire site, because it connects the 3 units. And for that, we're gonna have Delson talk to us about our CMU exterior wall.
Yeah. So I have put together a quick presentation on what CMU is, if for those that do not understand. So CMU is just a concrete masonry unit, CMU for short. They're usually versatile blocks that are made out of concrete that can be used both for structural and aesthetic looks. They serve both purposes. They're a great material to use because they're so versatile. Building is putting together is a little more tricky and time consuming, but they last a very long time. And happily, we're gonna use them in this project for a big portion of the project. So a little bit of the properties of a CMU is it is really thermal. It does absorb a lot of uh, its exterior temperature and can retain temperature very well and release it in the night and warm up in the daytime. So you can keep your interior temperatures more warm without having to actually have AC or much ventilation. It's really good for insulating. It does not mold. It does not rot. So that's why it lasts so long. This CMU wall will be placed near our elevator, which is um, in fact it works perfectly there because as it says here, CMU is R rated. So this means that it is a 2-hour rated for fire protection. So it takes 2 hours for fire to get through the CMU, and it is by code that we will need that for our elevators. So where I got our CMU is from BIM Smith Market. This is a great website that you guys can go to, which you can get free CMU add-ins to your project. I didn't write it down, but I used Old Castle. They are a company that has insulated CMUs as well. So I thought it was a good addition to our project because it will add another layer of installation. BIMsmith is really easy to use, free, as I said, to download, and has a great variety of not just CMU, but appliances and other crucial components to your project. We chose CMU because it is versatile for us and will allow for airflow in our building. This CMU that we're using is not exactly like these blocks that you see here, but we can use them in the same amount, style, and in different cases we will use them for openings that I will show you examples of right now. And we are doing a similar concept to this. I have done many openings like these. As you can see, CMU does allow a lot of versatile openings throughout the building, which not every material can do, but CMU, it is structural and strong enough that it can support its own weight. So it can have openings as long as it has a beam across the top to support any big openings. But most of the time for smaller openings, we will not need them. The block is strong enough for it. The also reason we also chose CMU is because we can have a green wall. So a green wall is just pretty much a wall where we can have vegetation like plants and other components growing out of it, and then not interrupting our airflow or any other important structures that we need. And it is bringing green into the multi-unit will help us a lot with bringing life into into the units and bringing some green into it. So
Now we're going to learn how to do it on Revit. So as you can see, CMU can give us texture, colors, patterns. We can create niches and openings. And now this is the way you would do it.
So in this project, I have already, this CMU wall is, I have brought in, has already been fitted with texture and the CMU that we will be using in this project, as you guys can see. But I will show you guys how we can input it. So I have, if I click on the CMU here, we can start a new one. So I started, so we're gonna start a new one from here. I'm just gonna, I can just duplicate this so I do not override my generic that I have in our files. And we're gonna go here into the structural. And as you guys can see, we only have structural and the thickness. We have no actual material used here. So I will be actually adding this in. I will click on these three little dots, which was open my material browser. I have, so here we have the three different CMUs I have brought into the project that we can use. But if I would not like these three, I can come down here and click on CMU by the company, by Insoltech. And I have a huge variety of CMU here. I have about over 150 different types of CMU, which is they all have the same properties. They're just different colors and different types of sizes. In this project, we're gonna use the Boston Blend. So I have already selected this material. Oops, sorry. And then I'm gonna go to graphic. So I go to appearance, and then I what it's gonna look like. This one's a more of a gray pattern, a more generic look, but I'll press OK. And then as you guys can see here that it has inserted the material that I want here, and then I just press OK. OK again, and it should be in place.
Okay, so thank you so much, Delson. Here you can see it on 3D, but I'm gonna go back to Edward and I want you to see the steps. So Edward, do you mind bringing back your slide? And because there's steps. One, you do first the grid, then you do the footprint, the parcel, then you do the footprint of each building. And then the next step is to draw the CMU. So Edward, can you draw the CMU?
Yes. So under the architecture tab, we're going to go to wall. And there are many types of walls. We can see here that one of them is a generic 6-inch masonry. So I'm going to click on that. Next, we wanted the wall to extend out from the units a bit. So we're going to click over here under 3D, click, drag it, and it's going to encompass all of the units. And put it over there. Click, hit the escape key, and now we can change the top constraint. In this case, we're going to leave it like that because after we set the levels, we'll be able to edit it. But you should be able to see it on the 3D view now. And there it is.
Thank you very much. And the next one, you're going to learn about levels. One of the things in Revit is, as he was drawing the CMU, you have to establish the levels because the walls are attached to the levels. And you're going to see it on Oscar Galicia is going to talk about levels and elevations. So our next step is to place columns. Oscar Galicia, are you ready?
Yes. All right. So columns. Columns are frequently used to support beams or arcs on which the upper part of walls or ceilings rests. Columns should preferably be located or near the corner of a building at intersections of beams or in walls. Start with the column base where the column of the transfer attaches to the foundation with an anchor bolt. These bolts come in various shapes and sizes. Because of these bolts are embedded in concrete, need to be embedded in concrete accurately. Accuracy is needed. Setting plates are used for this purpose. Some of the materials for the columns are reinforced concrete, which are first you design it, then you place the concrete on the material on the load, and it's compressed by steel frame to provide reinforcement. The next is wood columns. Wood columns are best used for porch, which are ultimately, even though there are various nice custom fiberglass and vinyl glass, they won't be able to come close to the same level of detail of wood columns. The next material is steel column. This material is commonly used. There are usually two types: the I-beam and the tube steel. The I-beam is used for major structures such as skyscrapers or other buildings that require large framing. And the tubular steel is commonly used for cross-sectional bracing. You can see a picture of the two being used in the picture right here. And these are some of what I'll do in some reference for what I'll do in the Revit housing. So
Yes, and
Hmm?
if you can stay on this for a second, so you can see the levels, and that's what we were talking about when Nelson and Edward were placing the CMU. So the CMU in this case is 40 feet. I think ours is going to end up being 33. But when that is where you see a concrete masonry unit, this concrete masonry unit can be made out of brick, it can be made out of concrete, it can be made out of mixture of plastic, and other structural materials and fibers and so on. But here you can see an elevations. This is looking at the building flat from the front view or the back view.
Yes. Okay. And yeah, and I have my elevation to 39 feet. I did this because when I was placing the roof, I was having some trouble with the roof. So I decided to just take an inch off of the masonry wall and then just give it to the roof. I figured that the problem was that I was not in the right place.
Perfect. So now let's move to Revit and show us how do we place the columns.
Okay.
Oh, okay.
Yeah, that was the other steps, but I just let's move on to Revit. So from the floor plan level 1, you want to go to the south elevation view. And from there, what you want to do is select on architecture tab, go to levels, and select levels. And what you'll do here is you'll place 3 lines. I like to place them right next to identical, like this. 1, 2, and 3. Next, you'll press the escape key and 2 times and head towards the levels. You and place the levels on these lines by selecting on them. The first one is gonna be the third level. We will and it'll be 20 feet. You can just place 20 right there, and next is gonna be this. You can rename these lines. This is good. You can just by pressing on it, level 3, and it'll tell you, would you like to rename the view, and then just place yes. The second one will be the level 4. And this one will be 30 feet. You can rename it as well as level 4. I'll tell you then yes.
And these levels are usually the top or the bottom of your slab.
Yeah.
And since we have 3 levels and then we have the roof, that's why we need 4.
Right. And the last level will be 40 feet. And this, you can rename it. Actually,
yeah, 5.
There's 5 levels.
Yeah, there's 5 levels.
Yeah. So the top level will be 40 feet. And next, what you want to do is go back to level 1 floor plan view, and go to architecture tab, select on column, select steel structural column. In structural column, you go to the property tab and select the Y shape column 10 by 30, 33, and you'll place it on the edge of this view. Around
And
there.
notice how right now we have it unconnected, but you can there have it connected. So you want to talk to them a little bit about that too.
Okay. I am having some trouble with mine. Yes, so you'll go to level 1.
So basically a column, you have different heights and you can have it connected to the level or unconnected. So click the arrow and put level 5 or level 4, click level 4, and then that should allow you to place your column.
Actually, it doesn't let me. Probably height. Yeah, that's probably. Yeah, so that was it. We can select the level. So this is gonna be, the base level is gonna be level 1, and the top level is gonna be level 4. The problem I had earlier was that my column was not in the correct setting. So when you select the beam, you first wanna check that you have it on height.
Perfect.
And then you want to place the top level, the level where it's going to go all the way up to. And then you'll place the columns at the edge. you'll be placing 4 columns. One right here, another right here, and the
It's
last
actually,
one.
it's 15. It's every
15?
15th. Yeah.
Every
So it's,
15.
yeah, it's right there.
Right here on the 15.
Yeah.
Yes.
And then once you have one footprint, you can just copy it into the next. And then let's show it how it looks on 3D.
Right. I think there's one that goes.
Delete that one. There you go. And delete
Yes.
the other one because, yeah. And the
Yes.
reason the CMU is taller is because it's going to have the handrail and it's going to be protecting also the roof guarding.
Yes. So thank you for my presentation on columns.
Now, did you have anything of the first floor? One of the things, maybe show us on 3D how it will look. The idea here is that that's why we study the 5 points of architecture, because the first floor, we will remove the cars on the weekend and then we can have a quinceañera, or we can actually utilize the space underneath. So can you show us a 3D or move it so we can see the bottom of it?
The bottom, like this?
There you go. Maybe we'll see it later on as we put the floors with Angelica.
Yeah.
Thank you very much. So now we have the columns, and of course we will add columns to the other ones, and then you'll continue seeing the development of it. Thank you very much, Oscar. Now let's see Angelica. So once you have, basically you're gonna have 4 columns, and then you're gonna have open web joist. And the open web joist is gonna connect the columns, and Angelica is gonna tell us about it.
Professor,
Are you ready, Angelica?
this is my presentation on the.
I don't hear you very well, Angelica. You want to check your audio?
Okay, this is my presentation on the web truss floor joist. So for architecture fall 2020. So what makes a building unique? A building is unique by its geometry and the way you design it. In this case, web trusses are stronger than joists. Just a little bit of web trusses and a foundation. An open web truss helps installation of wiring, duct work, and plumbing. It can also be used for lighting fixtures and sprinkler systems. That's when it goes on the roof. Parts of the web trusses are made of cords and verticals and diagonals. The insides, cutting the floor trusses is very straightforward. All you need is a saw that cuts 90-degree angles. These are a few of the thin web trusses. Types of the open web trusses: rim board, steel joist, rough trusses, rim joist, floor trusses, long span. This is a collage on the few of the web trusses, installation, CAD details. What is the importance of web trusses? It reduces vibration, it provides performance. How open web trusses impact architecture. The open web trusses came out in 1960. They are great on commercial building. They can be left open as part of the roof. They provide a sort of good and feel psychology. Web truss in Ames house. The front of the house has an open web truss. It's over corrugated metal on the roof. So now I'm going to show you how to put it over
on Revit.
On Revit. Okay. So basically this is my 3D view. So I'm going to go ahead and start on the 3rd level. So I'm going to go ahead, open up 3rd level. So basically I'm already on the command, but basically go to structure, beam. And I want to go here and I want to pick the G joist girder. So 16 gauge. So go ahead, zoom in, start from one end. We want to place these web trusses right in between the columns. So go ahead and hit escape once. It's okay if it doesn't connect. It'll still let you. And go ahead and hit the escape key after this. Go ahead, go to the other middle of the column. Connect to the other one. And go ahead and hit escape. Zoom in if you need to. and go up to the next column.
And here you can see the columns that Oscar was talking about. You can see now the layout is every 15 feet. You also see right now, Angelica is showing you, she already has the floor and the opening of the elevator on the right and the stairs on the left. And we're gonna talk about that in a minute.
Basically,
we lost a little, there you go. Your voice was out for a second.
Sorry, Professor. So right here, it's on 3D. The web trusses are here. So I'm gonna go ahead and add my slab. So I go back to my model of level 3. I go to architecture and I click on slab, or is it structure slab? And go ahead and go to my line command. Make sure you're on your level 3. And
Very
go
good.
ahead. And I want to zoom out and zoom back in, and we're gonna start right here. I think it's just right here. So I'll go ahead and start here. This one doesn't start there. So let me hit the escape key and it starts more over here. So let's go here, start here. Go ahead and go down. You kind of just like trace where you have been. It's not there yet. So let me go ahead back to the line, and here we go. Now we're off. Okay, go ahead and just go over the outside. You want to use the outside for this one, and want to bring it all the way out here. From here, you go just to your openings. You create your openings. You go 9 feet. You go 5 feet. You know, every space of the grid is about 5 feet. So right here, we just want to make sure we're closed. When we're there, we want to hit the check button, and the check button will give us our slab. So this is our slab right here. And let's go ahead and look at our 3D view. And this is a 3D view. So that gives us our slab with the web truss.
Very good job, Angelica. And then what we did on the right now, you're going to hear about the elevator, and on the left, you're going to hear about the stairs. So now you can hear where our columns are, and then how the open web truss connects to the CMU. Do you have a detail again of how the web truss connects to the CMU? So these stages you're seeing here are very similar to the stages of construction.
Best detail I have right here, it's this one right here. So is it this one? Okay.
Yeah, that's a good one. That's a good one. So there you can see the open.
It just connects from here. These are the web trusses right here, corrugated metal, and this is the pour over concrete and installation. You bolt onto the CMU wall, and you go all the way around and connects to your curtain wall and everything right here.
Perfect job. Very good job, Angelica. Thank you. So now you guys, as you know, now we have the floors, we have the open web truss, and this is a similar way that you will build this building. It's almost like a process of construction. So now we're gonna add the stairs and add the elevator, but before that, we gotta protect it. We gotta protect it. So now we're gonna add the roof. And the roof can have different shapes and sizes. And for that, we're gonna ask Erica to tell us everything about the roof. The roof will protect the stairs and the elevator, and it could probably extend into a canopy. And with that, we have Erica. Erica, you wanna tell us everything about the roof? Go. Thank you, Erica. So tell us all about roof.
All right, so for the roof function here, what is a roof? It protects against weathering, change in climate. It provides support to the structure when building the top of the roof. The function of the roof is for insulation. It keeps the house warm in the winter and cool in the summer. And it's really important for those features, for protection. And it also provides protection from the elements, saves energy, adds curb appeal, and so forth. So. All right, so these are the different parts of the roof that I'm going to go into detail about. And there's all kinds of roofs that you can pick from, as you can see here. There's different materials, various colors that you can make for your roof. And here we have the construction details and the math behind it all, like sizing, dimensions, and whatnot. And for the roof, we have green roof, and what that means is that it provides, stuff for roof gardens, and it reduces storm water runoff and helps cool the roof and the building overall. It really reduces heat island effects and extends the expected life of the roof space material. So it really provides a lot of structure and all of that. All right, so here's the roof in Revit, and you can make any kind. You can be very creative with it. You can have, pitched roofs. Really, you can do anything that you'd like for a roof in Revit.
And now, like the other ones, she's gonna show us how to place the roof on our multi-unit. So you could have a roof for the entire 4, or you can have a roof on each of the units. So I'm not sure which one Erica has chosen. She's gonna open Revit and show us how to place the roof. The roof also can have different thicknesses. In our case, we're gonna put solar panels and photovoltaics so we can produce our own energy. We could also have skylights above the stairs so they can be very bright and light.
We're gonna make, the roof here. So again, you can make any kind, and right here, you set up the corner. Right here, you start from the corner. And trying to find in here, hold on 1 second here. I might have hit the wrong thing here, 1 second. Okay, so you want to set up the structure for it, the walls, because the roof connects at the corner. And then you select the different levels here. You can see that. And then you drag it. So yeah, as you can see, I'm dragging with my cursor starting from the corner at the intersection. Or maybe it's something wrong that I'm doing here. 1 second. Okay. Oh, it froze.
I think she was saying that the size is, it's up to you, whatever size you want to use.
All right, and after that, you have the overhang, so or offset. And then you want to put that so that they connect up top. The
Unchain, was it unchain?
unclick, you want to unclick that because you don't want there to be a slope, you want a flat roof. So that's important. As you can see here, I'm dragging this and I'm clicking on the south elevation. And it's important to make sure you're doing this on the correct level. This is the top level. And going into 3D view. Loading.
So now we're gonna continue with Matthew Aguirre-Mate. He's gonna kind of bring all together and talk about curtain walls. Very quickly, he's also gonna remind us about the columns and about how to make a roof. So thank you, Matthew.
Sure. So hello, everybody. My name is Matthew Aguirre-Mata, and I'm going to try to make this short, sweet, and straight to the point. So give me 1 second. Can you guys see my screen?
Yes.
Okay. So what makes our building unique? So for our Revit model, we have created customized curtain walls for a multi-unit house. These curtain walls will be composed of green recyclable materials that facilitate cross ventilation throughout the entire building. And these curtain walls can be beautified with the addition of green vertical trellises to create these green walls. So what are curtain walls? A curtain wall system is thin and lightweight and usually aluminum and glass, and all of these walls are not structural. So by design, they are only able to carry their own weight while transferring the load of wind and gravity to the structure of the building. And they are also utilized only to keep the weather out and the occupants in. So the four main components of a curtain wall include the transom, which are the horizontal rails, the mullions, which are the vertical rails that are anchored to the beam, the vision glass, as well as the anchor. And there are two main types of curtain wall systems. So the first one would be the stick curtain wall system. So these walls are installed piece by piece. And we have the unitized curtain wall system. And these systems are made of large units and are erected on the building facade. And here I have a collage. So if you look on the left-hand side, you have 4 pictures of the unitized system. And over on the right, I have 4 pictures of a stick system. So one major advantage of today's curtain wall is that it can be constructed from much lighter materials such as glass, which allows for the filtration of natural light into the building, such as appearance and attractiveness. And in addition to preventing air and moisture from entering the building, curtain walls also act as a fire stop, slowing or preventing the spread of a fire between floors of the building, also known as thermal efficiency, and it also reduces building sway. So curtain walls have the primary purpose of keeping air and water out of the building, essentially acting as both a buffer and an insulator. Glass curtain wall systems can provide added structural stability for tall structures that can reduce sway, to protect against high winds and ecological events. And these curtain walls also give a clean, sophisticated, and unique appearance, which is now associated with contemporary design. So a little bit about curtain walls inside the Ames house. So when looking at the structure element made of steel, the Ames wanted that steel performance to be visible and recognized. And a majority of the home's perimeter is made up of windows and provides for an outward connection with nature. The placement of the different types of glass served as a rigid purpose, but was sometimes an additional aesthetic bonus. In terms of aesthetics, Charles noted that the addition of glass and reflections restored transparency and added double images that become characteristic of the building. As well, he also made the point that the planes and shadows caused by the wire pattern and some of the glass became an essential visual feature. So a little bit about the Via Savoia. So the absence of load-bearing walls allows making windows of any shape and size. The horizontal windows cut through the non-load-bearing walls along the facade and provide the apartment with even light, as well as increase the level of insulation and increase the sense of space. It also provides the interior a lightness and offers views of the surroundings. So here are the steps to create a curtain wall, which I will explain thoroughly later on. So you guys can always refer back to this presentation so you can have a better understanding of the steps explained. And lastly would be the facade tectonics. So facade is an exterior wall of a building, usually a face of a building. Tectonics relates to the building or construction. And FTI is a nonprofit member organization for the AEC industry and research and education institution focused on healthy buildings and livable urban habitat. The institution's mission is to accelerate transformative change in the built environment toward common goals of resilience and sustainability. And just a couple roles in regards of the FTI would be expanding recognition and understanding of the integral role for the facade system, which plays in resilience, sustainability, energy efficiency, durability, health and productivity in buildings and urban habitat, as well as accelerating innovation and tangible improvements in buildings and urban habitat through strategic facade-based initiatives, as well as providing the industry-leading platform for building facade, knowledge sharing, communication, and collaboration. And finally, this is a CAD detail of the curtain wall system. So if you look very closely on the left-hand side, you can see the different types of parts that go within a curtain wall, such as the transom, the mullion, and the thermal insulation spacer. And if you look on the right-hand side, you can see the glass panel and just a little bit more details as far as the mullion. So this concludes this presentation, Professor. So let me unshare my screen and jump into Revit. So can you guys see my screen?
Yes.
Okay, so let me start off with doing the columns first. So let me just jump into level 1. So real quick, I'm gonna look up on the ribbon and I'm gonna select column. So for this example, if you look on the type selector list, we use the 10 by 49. So I'll go ahead and select that. And then I wanna make sure I have height and not depth. So it could go above ground and not below. And then I would like to have my placement level. It would be on the height would be on level 5. So I will start off on level 1 and the height would be up to, level 4. So it's very self-explanatory to do. All you have to do is just make sure that your level placements are correct. And then you just kind of click and place as you go. So just give me a couple seconds. Hopefully it doesn't freeze or crash.
That's one of the things with Revit, you gotta be patient because it is very memory consuming.
Correct. So like I said, as long as you make sure that your base level would be level 1 and the height would, the top of it would be at level 4. And we're just gonna kind of mimic what the building right here on the right-hand side. Go ahead and click placement. And it's a lot easier when you see these dashed lines because that's when you know that it's aligned properly. So after I do that, let me go ahead and jump into 3D view. And you can see that I have placed all of my columns properly. So next would be the curtain walls. So let me jump back into level 2. And going to the curtain wall, it is, like I said, it's very self-explanatory to do. So the first step would be to go to architecture and you want to click wall. And if I look under the type selector list, I have a variety of walls that I would like to use. So for now, I would like to use just a basic curtain wall for now. And then I would look at, make sure it's at height, once again, and not at depth. I would like this to go all the way up to level 4 and just confirm that my base constraint on the left-hand side in the properties is set to level 2. So I'll go ahead and start by zooming in. I'll click at the end. And then I notice that the curtain wall is going outside. So all I have to do is click the spacebar to make it go inside. Zoom out. And go all the way to the end. So it's just kind of, like I said, it's very self-explanatory. You just kind of click and place as you go. So if I go to my 3D view, I could confirm that I have my wall set right in place. So if I just cycle through the tab, you can see that I have my curtain wall in place. And in order to create a customized curtain wall, it is fairly simple. I'm gonna go ahead and highlight the curtain wall, click edit type. And then I would like to duplicate it. So you could duplicate this wall. That way you could save your own customized curtain wall. I'll go ahead and click cancel. And there's a variety of things that you could do. So the first example would be if you want to add mullions. And like I said, the mullions are the horizontal ones. No, I'm sorry, they are the vertical ones. So if I want to add any type of mullions, let me see. So for vertical, I would like to, just for now, let me think. Just for example, I'll just use rectangle mullion, 2.5 by 5 inch. And I'll go ahead and just make all of these the same. And then for, let me see, let me click apply. And now you can see that I have the mullions around the perimeter of the curtain wall. And then I could do the same thing with the horizontal mullions. So once again, just from using the edit type, you can always add or change the mullions or the transoms to be specific, as well as adjusting the spacing. So to go over real quick, the spacing, you want to look on vertical grid. And yeah, it's right here. Give me 1 second. So I go to fixed distance. Okay, there we go. You want to change the layout to the fixed distance. That way you can activate the spacing for the proper column. So once you go to the value column, you can now adjust the spacing. So if I want to, just for example, let's make it an 8-foot spacing, I could just go ahead and click apply after I change it. And now if you look back to the 3D view, you can see that I have added 8-foot spacing. So once again, let me do this to the mullions. So I go right here to the value column, change from none, and let me go ahead and change it to fixed distance. And let me make this one 10 feet, for example. I click apply. And now you can see I have added a mullion going straight up and down. So you can, like I said, you can go ahead and just change this to any type of dimension that you want. So I'm gonna go ahead and just leave this for now. And I will jump straight into the roof. And
Perfect, good job.
And in order to add the roof, I'm gonna go ahead and jump all the way up to level 5. And let me just zoom in real quick right here. And just to make things a lot easier, let me go and click VB, which is a visibility graphics override, or as well as VG. And I would like to disable the grids. Just so you can get a better visual of what's going on in your model, click apply and click OK. So I will start off on the roof by going to the architecture tab and make sure I click on the roof inside the ribbon. So I'm just going to use just a generic 9-inch. I just think it's very easy to use. And then you just kind of click at the endpoint. And we're going to go all the way to the right. And then I'm going to extend this out so we can have a 5-foot overhang on the right-hand side as well as the left. So once I get to the edge, I could just type in 5 on my my keypad and click enter. And I'm gonna have it come down, I believe it's 15 feet. Someone correct me if I'm wrong.
That's great. And we're drawing a flat roof, which is perfect.
Correct. So now I can see it's at 110. So 110 plus 5 would be 115. So I'll go 115 horizontal. Then I should go up until I see this dashed line. So that's when I could confirm that it is even with the other horizontal line. And then in order to complete a roof, like I mentioned before, as well as floors, you want to make sure it is a closed polygon, because if it's incomplete, you will get an error. So after that is done, I'm gonna go ahead and click check. Would you like to attach? I'm gonna click don't attach for now. And if I go back to my 3D view, you can see I have added the roof, but you know, for this example, the levels have to be adjusted. So all I have to do is just change the level to make it, because for this model, I think it's 33 feet, which is not a big deal. All I have to do is just make it 36 feet. I'll see if I could do it real quick. Go back to my 3D view.
What happened is that the third level doesn't exist because it's just the first, the second, yeah. And then we just need to extend the CMU too.
Right, so you can either extend it by pulling this all the way up to make it even. And as you can see in my 3D view, I have added my roof, the curtain walls, and as well as the columns. And to conclude this presentation, I would like to end off with this very powerful quote. Now, this is not the end. It is not even the beginning of the end, but it is perhaps the end of a beginning. So thank you everybody for watching my presentation, and best of luck to everyone. Thank you.
Fabulous work. Thank you so much. You have become an expert. Very good, Matthew. Very good. So now we're gonna move to Adriana. Adriana is gonna tell us everything about elevators and interior walls.
Hello everyone. So today I will be presenting about interior walls, doors, and elevators. What is space planning? Space planning is a fundamental element of the interior design process. It starts with an in-depth analysis of how the space is to be used. The designer then draw up a plan that defines the zones of the space and the activities that will take place in those zones. The space plan will also define the circulation patterns that show how people will move through the space. The plan is finished by adding details of all the furniture, equipment, and hardware placement. Some aspects to consider when doing interior walls is function and zoning, dimensions of shape of the space, site orientation and climate, circulation patterns, storage, permanent fixtures, and special needs for elderly or disabled users. Why interior walls are important? Walls define living spaces offering privacy for bedrooms and baths, directing foot traffic, and creating functional floor plans. Some important facts to consider when doing interior walls are load-bearing versus partition walls, wall height, wall thickness, framing standards, and wall construction methods. Sorry, I don't know. Can you see my screen? I don't know, something happened. Professor, you are muted.
Yes, you can see it, no worries.
All right. Okay. Load-bearing versus partition walls. Interior walls consist of both load-bearing walls and walls that don't bear weight, called partition walls or non-load-bearing walls. Both types of walls employ similar framing standards, but a load-bearing wall is a typical located directly above another load-bearing wall, a beam or a structural column. With this image on the right, you can have a better idea on how bearing and non-bearing walls function. As you can see here is the load bearing, and the wall is supporting an imposed load, and then the non-bearing wall is supporting supporting no load other than its own weight. Wall height. Standard ceiling height is 8 feet from the finished floor to the underside of the ceiling drywall. Wall thickness. A 2x4 wall stud is 3.5 inches wide, and an interior wall typically has 1.5 inch drywall installed on both sides, bringing the wall thickness to 4.5 inches. Walls that contain plumbing, such as walls behind sinks, should be thicker than standard walls. 2x6 wall studs are 5.5 inches wide, and they provide larger stud space for running drain pipes, air ducts, or other mechanical elements. With the addition of drywall on both sides, a 2x6 wall is 6.5 inches wide. Framing standards. In a standard interior wall, correct stud spacing is essential. Standard studs are 16 inches apart, measured from the center of one stud to the center of the next stud. For second story load-bearing walls, which sit directly over load-bearing walls on the floor below, the best practice is to align the wall studs from one floor to those on the floor below. This means that the wall studs on the floor above will be directly over the wall studs on the floor below, even though horizontal wall plates, floor joists, and subfloor materials separate the wall.
Now we're going to move into Revit of how to actually place the walls and the elevator. Fabulous presentation, Adriana.
So doing walls is very simple. You go to the architecture tab. You select wall architectural. Make sure that your location line is finished face exterior and that you are in the correct base constraint. Right now, I'm gonna do the walls for the level 1. And also make sure that the top constraint goes to level 2. So the wall that I'm gonna do is from here to here, 10 by 10. And to place the elevator, since I already downloaded to my project, you just go to component, place a component, you go to the type selector list, you select the elevator and you place it there. Okay. Now let's go to level number 2. Here I'm gonna do the walls for the bathroom, the storage, and the laundry room. So again, I go to architecture, wall architectural, location line, finish face exterior, base constraint level 2, top constraint, make sure it goes to level 3. You wanna your walls to go to the level above, sorry, up. So I'm gonna do a rectangle. Now I'm gonna divide it. and I'm gonna start placing the doors. So for the doors, you go to the architecture tab, you select doors, and I'm gonna use this one for the bedroom. You can use the space. Why don't rotate it?
So notice how by creating a 5-foot module, we'll be able to create basically 2 aisles and then the circulation in the center. So this design, the interior can actually move based on what the client requires. And you're going to see more examples of these with when Chris presents the interior furniture.
So this one is the door for the storage. I just want to make sure what type of door I am.
Okay, we're going to move to the next one. At least students were able to see how do they place windows and doors and the importance of interior walls. So thank you so much, Adriana. We're going to move to Erin, and we're going to learn more about walls afterwards with Chris. Great job. So Erin, tell us all about stairs. Stairs are complicated because they are regulated by the building code. The thread and the rise, according to the building code, cannot be more than 7 or smaller than 6.5 because it can create hazardous. It can be dangerous. And then also the stepping, the tread has to be minimum 10 feet. So Erin is going to tell us how to calculate it and actually how to draw it on Revit. Erin, please.
So should I just do Revit, or should I show you my PowerPoint presentation?
Well, if you have 10 minutes, so
Oh,
if you
yeah.
can do 5 on 5.
Can you see my screen?
We can.
So very quickly, just what stairs are. Just a construction designed to bridge a large vertical distance by dividing it into smaller vertical distances called steps. The stairs, they can be straight, they can be round, or they can consist of 2 or more straight pieces that are connected at angles. And then just some general anatomy. So your tread is where you actually put your feet and you stand on. And the riser is the space in between the treads. And then the nosing is the portion of the tread that overhangs the front of the riser. And then the railing system. So the post is the vertical structure that connects the stair or the floor to the railing system. The rail is actually where you put your hands on, and then the spindles are these vertical structures that are in between the posts, and they're there for safety reasons. And then the shoe is the bottom plate that the spindles will sit on. Sorry about that. And then the stringer is the surface that holds the risers and treads in place. So the stringer fascia is the finished surface that is on the inside vertical surface of the stringer. And the stringer capping is the finished surface on the top face of the stringer. And then the shoe mold is the molding that covers the gap between the shoe and the drywall surface of the wall below where the shoe is installed, so right here. And then some different stringer types. You have your Western, which is when your stringer is this kind of like this long continuous ribbon, and the treads and the rises are inside the stringers. And then with your Eastern stair type, the stringer is cut along the path of the stair path. And then another stringer type are monostringers, and they use this single beam like stringer that supports the center of the tread from below, and then no risers are present. And then these are a few different stair types. Going from left to right, you have the straight, the L-shaped, and the winder. And the U-shaped, which is what we're doing for our project, the spiral and the curved. And then this bifurcated, and then a step ladder. And then this is kind of like a blown up isometric view of stairs. Very informative. It kind of tells you how you would go about building them. So if you can see my mouse here, it says that the balusters have to be 2 by 2 and have to be equally spaced and have to be fastened to to finish the tread, only 2 per tread with the 3/4 double-ended dowel screws. And over here it says that the finished tread, return applied to tread edge with stair tread with adhesive and finished nails. And then you're gonna wanna fill the screw holes with wood putty matching wood species of finished tread and riser. And then this is a section view of a landing of a set of stairs. And then you have a floor plan view of another set of stairs and a section as well. And then just kind of very generally how you would go about building a set of steps, a set of stairs is you would first want to collect the measurements. And then with that, you could calculate the slope. So then you could carve out either by hand or with the machine where the risers and the treads would go. And then you would hang the stringers relative to the right levels. And then you could install the risers and the treads. And then you'd be able to install the staircase if need be. So now I'm going to go ahead and I'm going to show you my Revit. See my screen?
We do.
Perfect. Okay, so the way I set this view up was that if you go up to view, I can't see it because of Zoom actually. There we go. So if you go up to the view tab, you can go to tile views and you can create this side-by-side view. So if you're working on a specific level, you can at the same time see the progress in the 3D model, which I think is really good when you're working on stairs. And then also, if you're in this 3D view, you can go to this section box and you could select it. And then this box comes out and you can crop out whatever you don't need and focus in on what you're just working. So I have all the other multi-units on the other side, but I cropped them out for the purposes of the tutorial. Here you go. So let's get started. So if you go to the architecture tab, you can go ahead and you can click on stairs. And I'm gonna start off with a -3 offset and you'll see why in a second. This assembled stair is fine for what we're doing, but other options that come with Revit are a cast in place stair and a precast stair. And then I'm just gonna make sure over here in the component section that I'm using a straight run and I'm gonna have it run left. So let's get started. All right. So I'm gonna click right here. Sorry about that. So also one more thing is that the desired number of steps that I want are gonna be 14, and that's to ensure that we have enough space for a landing to get onto the first floor. All right, and you can just click OK right here. And I'm gonna click here. And there we go. So the reason why I gave it a -3 offset so that there's this space between the CMU wall and the stringer. And I'm gonna go ahead and I'm just gonna create 8 risers. So right now we have 8 risers and the desired number is 14. So I'm missing 6 and we're gonna do that. That part of the stairs are gonna run parallel to the ones that I just created. So I'm gonna go ahead and I'm gonna change the location line to run right. I'm gonna remove this offset. You don't need it anymore. And I'm just gonna move my mouse over here and I'm gonna make sure that it lines up with the last riser that I created. And I'm gonna click. And what's going on here? Let's see. Oh, there we go. That was weird. Okay, so I'm gonna click and I'm just gonna go ahead and complete the stair. So now 6 risers created, 0 are remaining. Perfect, and then the landing is created on its own and you can see the progress right here in the 3D view. So this is what we have so far. So now what we need is to add a landing. So I'm gonna go ahead here and I'm just gonna click on landing. And I'm gonna click this pencil looking button here and I'm gonna sketch this in. So I'm gonna click on this rectangle. And here we go. There we go. So then I'm gonna click on this corner here. And this grid line right here is where the floor begins. So I'm gonna wanna line it up right here. And that should be perfect. So now we have the stairs and we have the landings and we should be good to go. So I'm gonna press check here and I'm gonna press check again. And right here, it says the rail is not continuous. Breaking the rail usually occurs sharply angled transitions to fix the problem. So Revit was bringing this up for me a lot yesterday. And then I thoroughly inspected the rail and I didn't see any breaks in the rail. But the big problem that we have here is that the railing kind of loops around the landing. So that's going to prevent us from getting to the first floor. So what I'm going to do is that I'm going to go to the modify panel and I'm going to select this split element tool. Focus on that. Okay, so I'm going to click this split element tool, and then I'm going to go to where the railing makes this right degree turn, this 90-degree turn. And I should just be able to click right here. And again, click over here. So what I'm doing is that I'm splitting the railing into pieces. I don't think I clicked it over here the first time. Perfect. So now I'm going to click modify and I'm going to zoom in on my 3D view. And now I should be able to just select this part of the railing and now I can just delete that. So perfect. Now we can get onto our first floor. And then to put these on the second and third levels, I could just select the stair. I can go over here and copy it to my clipboard. And then I'm going to press paste. And then I'm going to select align to selected levels. And I'm going to move this to level 2. I'm going to align it to level 2. All right, actual riser height of stairs greater than the maximum riser height of specific. In the stair type, we could ignore that. And then I'm going to do the same thing again. So I'm going to go to paste. I'm going to go to align to selected levels. And then I'm going to go to level 3. And then the warning's probably going to come up again. Get rid of that. And here we go. Here are our stairs. Professor, do you want me to edit them and add the materials?
Yes, if you have some time, that'll be wonderful.
Sure. Okay, so the way you would go about this is that you would select on the set of stairs. And then you would go to edit type. And here you see the supports. So these are the stringers that are just come with the default set of stairs. So I can choose to remove these stringers or change the support or change the type of stringer. And then if I go to this run type and I just press at the end right here, it's going to take me to this other tab and it's going to allow me to edit the materials of the treads and the risers. And to do this, you would just select right here and then you could pick whichever material you want. So I actually, just to save time, I did all of this and I created a different set of stairs called red oak finish. And you can see here that the stringer is made of red oak, both stringers, and that the run type, the tread material is oak, and I got rid of the riser. So it kind of gives for a more modern look. We'll see right now. Okay, so this warning says that the stair top end exceeds or cannot reach the top elevation of the stair. So the reason why that's there is because the desired number of stairs now is 18, but we only have 14. So we would need an additional 4 steps to go to the first level if we want to keep it like this with 18 steps. But if I just change the desired number back to 14, select apply, ignore that, we should be good. And there you go. That's a set of stairs. And then you could just do the same for all the other ones. Click on this drop down and then select the red oak finish. Again, the same issue. So I'm going to make the desired number of steps 14. Okay. And I'll do this again for the last one. Red oak finish. Make this 14. Ignore, and we should be good to go. And then if you want to edit the railings, you could just select on one. And then by default, Revit will give you these bottom ones right here, the glass panel all glass, the bottom fill, the guardrail pipe, rectangular pipe, handrail pipe, and then the handrail rectangular. So if I select on the handrail pipe, I actually edited this one a while ago, but it'll give you a default version of this exact same one. So it won't have any materials. And what you would do is that you would select the railing, you would go to edit type, and then you could edit the rail structure and you could change the materials. So the original one didn't have any materials and I just changed them to black steel. And for the top rail, you would go to type and then you would click on the end here. And then you would go down to materials and finishes and you would be able to change the material here. So it won't have a material, you would have to add it in. So you would click this. And then again, you would type in the material that you're looking for and then you would press OK, and then you should be good to go. And there we go.
Fabulous work. Fabulous work. Very good, Aaron. Very good. So now, guys, what's next? Now we are going to have Chris. Chris is going to show us a little bit more about the options that we have with the interior walls and then how to do furniture. Well, you can use furniture that is found inside Revit, or you can actually go to multiple sites like Delson shows us and then download customized furniture. And with these, I leave you with Chris Gonzalez.
Hi, everyone. So I'll be focusing more on the interior space, as Professor Oliva said. These are the key points that I will be hitting. So Adriana already hit the space planning pretty perfectly, so I'm just going to skip over that and jump right into circulation. So what is circulation?
Actually, Chris, do you mind going back? Because I don't think she covered that. Do you mind going back?
Oh, really? Okay.
Yeah.
We are.
Oh,
So
wait, no.
definitely talk about that one you did.
Okay, space planning, sure.
Yes, just do your whole presentation.
Okay, so space planning, what is it? It's an in-depth analysis of how physical space is used inside of structures. It also helps ensure efficient use of the floor space by organizing the space, furniture, and functions and how they work together most effectively. And what to consider most in a residential unit when space planning is what size is the family, the location of the site, the number of levels that you have, and also the family, how they intend to use the space and what activities they want to use. And this is an example of our multi-unit and the roof level. So for circulation, what is circulation? In architecture, it refers to the way people move throughout a building and how they interact with the physical space around them. Circulation also occurs prior to entering the building as people approach the structure. Different types of circulation include the direction of the movement, the type of use, the frequency of use, and also the time of use. And what to consider most when developing circulation is the fluidity of the circulation. Does the circulation route clash with furnishing requirements? And also the size of the circulation spaces may be determined by factors such as the number of people using them, the direction of the travel, and the crossing flows. So as you can see here, here is a visual circulation of our multi-unit, the main level, and just focuses on where people will be going in the direction that they'll be going to get to their location. So an open floor plan, what is it? An open floor plan is in residential architecture refers to a dwelling in which two or more common spaces have been joined to form a larger space by eliminating all of the partition walls. And aesthetically, it brings a sense of openness and greater traffic flow, which is promoted in open floor plan. So as you can see here, that is exactly how we developed our multi-unit complete open floor plan. The dining room is attached to the living room and as well as the kitchen space. So the advantages of a floor plan are a better traffic flow, improved sociability and communication, shared light, also layout is flexible, and the spaces can be multifunctional. So for a flexible floor plan and conversion, so the beauty of this layout is that the unit allows the ability to renovate and to convert it into 2 units instead of 1 main family home. So as soon as the family downsizes, you can make level 3 and you can convert one of the bedrooms into a kitchen and dining space. And in level 2, you can add a partition wall and create a bedroom or create a studio space layout. So in this photo, you can see that it is the top level. So it has a 3-bedroom and a bathroom. And so this is what essentially can happen. You can convert from the 3-bedroom into and create it into a kitchen unit, as you can see here. So also proportion and scale in interior design. The role of proportion in interior design is super important. It's essential when selecting basically everything that comes inside the unit, the furniture, the decor, the window coverings. And also in residential design, scale relates to the size of an object compared with the space it occupies, while proportion is concerned more with the relationship of elements to one another. So what to consider when using scale and proportion to interior design: leave room for negative space, use the golden ratio as you see here in this photo here. Ensure that all furniture is to scale design elements to a room's ceiling height, and also design around your most important piece of furniture. So lastly, Revit objects. So where do we download Revit objects? So Revit already comes equipped with an English Imperial Library, where you can find a select amount of Revit objects, but luckily Revit is has an open source agreement, so which allows every and any user to create objects for their program, make them accessible to everyone. So these are a couple of websites that are most used for free downloads for Revit objects, so that way you can furnish the interiors. So that's how I'm going to start first and show you how it's done on from the website. Are you able to see my screen as I move to Revit City? Or shall I share again?
We're still on PowerPoint. Yeah, I think we need to share. Okay. This is fabulous job.
So to start off, what you would do in order to, like I showed on the last PowerPoint slide, is you would go to a website such as Revit City. You would type in the keywords as to what you're looking for, such as sofa, shower, anything that you're possibly looking for. And so this is the sofa that I chose to furnish the inside of the multi-unit. So what you would do is you would click on download now, and it will appear here. And the best advice I can give you is to create on your desktop a Revit materials folder. So as I did here, you can create Revit materials folder and add that in there. So say to furniture. And after that, we will continue on Revit, and you can do this for all of the objects that you find on for your unit. Okay, so then as you get to Revit, can everyone see my Revit?
Yes.
So after you've loaded or downloaded all of the objects from the different websites, you can load them into your project. Sorry, I'm having the same problem Aaron had for not being able to see the top of Revit.
And we can see it fine. That's interesting.
Okay. So, so to start off, the components that we'll load, you will start with component, which is under the architecture tab. And you will go to load family. So if you have created a Revit materials library, you will be able to easily find what you were looking for. So to start off, the dining table, and also remembering exactly what the title of it is helps. So dining table, you would press open and it should appear. I've already loaded it, so I don't need to load it again. And it should appear in your screen. If it doesn't appear on your screen, look at your properties tab and you can see all of the objects that are loaded. So to start off, I will start placing some of the objects. So for the couch, you can also press the space bar to change the direction as to which way you want to place your furniture. And you can generalize it, not too close to the wall, not too close to the door, and everything is shiftable. So no need to be so specific on the first go. And you'll just continue doing this with all of your components either you will load it again, or you can load all of your components in at the same time. And since mine are already loaded in here, I will place just a couple more just to show you. So I will find the dining table. And as you can see, once you start adding a lot of components, it can really stack up in here. So for the dining table, same thing. You can press the space bar to change the location. I like it like this. So place it like this, and we're creating the open floor plan space. So also, I had already had some components loaded in here, as you can see. So when it comes to the space planning, I have the washer and dryer set behind the front door. So that way it's kind of out of the way and it takes space of the bathroom. Also, I think it's important as when you are entering a bathroom, you are not staring straight at the toilet. So I placed it over here in the corner so that way you're staring at the sink and the mirror, which is a little bit more aesthetically pleasing. And also for the kitchen. For the kitchen, it's nice to break up the space with some type of furniture, such as a bar space or like a table area. So I added bar stools here, and it has a kitchen stove. But and you can still see that this entire space has the open floor plan that we are aiming for. I don't know if I should place a couple more components or if it is explanatory.
Yeah, it's very explanatory. If you can just walk us through your entire, the first floor where the parking is, and give us a view of how it will look. Then first floor, second floor. Just walk us through your whole building since you will have everything completed.
Sure. So for level 1, since it is an open plan for to be able to put parking here, so you will just have a small wall here where you enter, and then you'll be able to rise up from the stairs and from the elevator. And for level 2, as you come upstairs, I did already place a couple components before where you can have like a slightly outdoor mudroom where you have a bench to sit down and a place to put your shoes, change into your house shoes, and come inside to the ultimate living space. And for level 3, you can also, I did not do it for that one, but for this one, you can have 3 bedrooms, or like I showed on the PowerPoint presentation, you can convert this unit into a kitchen. And lastly, on level 4, it will be the rooftop area. I have not furnished this one quite yet, but I did add a pergola-like structure, so that way for shading purposes. And that is what I have right now for.
You can show us the 3D and then show us like the multiple axonometric so we can also see it on 3D.
Okay,
Is this your final one?
This is not my final one. So if you want to give just a minute and I will.
Yeah, 1 minute. Let's open her final one because you're going to be able to see the entire 3 units. And the most important is the spacing in between. So the spacing in between facilitates a lot of interaction, either for 3 families or up to 6 families, as we saw. So she's going to show us how to look at it from multiple axonometrics. Here we go. And so in a day when there's no when there's no cars, you can turn it into an entertainment space. That CMU still can have a lot of openings, so you can actually also create like a running track around the case. So just quickly, yeah, if you can rotate it around. Fabulous design. And again, we can have up to 4 units. So we could even have up to 8 families living or 4. And this, instead of having 15 feet in between, we could have 10, and it still will be very spacious. And as we were talking about, that CMU can actually have, I'm going to show you in a second, some niches and openings. So beautiful design. Thank you so much, Chris.
Thank you.
We're gonna ask now Edward to show us how to do a handrail, and maybe see also you were able to see the roof that Chris designed, but now let's look at Edward. Edward is gonna show us how to add handrails, and then after that, Daniel Ramos is going to conclude and tell us all about the regulations for the parts.
It's just going to take a second because my Revit is loading. It's taking a really long time.
All right. No worries.
You might want to stop the recording.
So now we're almost there. We're gonna add the handrail on the roof. And here we have Edward.
Hi again. So putting railing is pretty straightforward. Erin already showed how to customize rails. For now, I'm just going to do the standard default railing. We're going to go into the architecture tab, click on railing, and then it's going to show you how to make the path for the rail. So right now we're going to do the area by the stairs just to cover up this hole so people don't fall in. And we're going to click at about this point, drag it out a bit, click. And once it reaches this curtain wall, we're going to click. And you have to do each rail one at a time. So we're going to click the green check mark. I'm going to go back to the architecture tab, click on railing again. And now we're going to do another path that's going to go around the actual roof. So I'm just going to have it follow this grid line over here. We're going to click, drag it, click, click again, click, drag, and then click. And then we're going to press the green check mark, and it might take a long time to load into 3D view, but yeah.
And I see that you have placed a canopy, so that is beautiful. So afterwards, you can show it to us on 3D.
Yeah, here it is. So this is what the standard railing looks like. You can experiment with different types of railing. And this is the roof with the canopy. I think people customize theirs differently, so everyone's kind of looks different and unique. But there you go.
Beautiful handrail, beautiful color. Can you walk us around a little bit more, Edward? In your presentation, just shows the elevations.
Oh, sure, yeah.
Shows the 4 axonometrics.
Okay, so in terms of elevation, this is the east elevation. The north is just a standard CMU wall.
Later on, we'll customize it.
So I have a green wall on top of the CMU in order to make the common area a bit more beautiful. The western elevation. And for the ground floor is kept open. I have a little area where you can keep your bicycle. The entrance, stairs, elevator. And then this is my floor plan for the first floor. It pretty much follows the basic modular design. You have the kitchen, 10 by 10, the kind of like a living area, a dining area. And then the second floor is pretty standard. You have 2 bedrooms, an office, a balcony, another restroom, and then the roof with the canopy and the hangout area.
Can you scoot back on this one just so we can see the whole model, and then go under your cube and just show us from multiple perspectives. I love your handrail.
It's loading.
And I see that also your roof, you extended it on the other side.
Mm-hmm.
On top of the CMU.
Okay. Oh. All right, so for different views, we can do an isometric view.
Yes, perfect.
This. And we can do a closer isometric view.
Beautiful. And you can see how the roof overhangs on the other side too. So it's perfect for like experiencing the whole site. We're gonna put like a running track around the site. Beautiful design.
You can have a front view, which is a more detailed view in the 3D. This kind of gives you a better picture.
Very good. And thank you all for staying here. You guys are almost there. Thank you so much. I'm going to show you one last thing before Daniel goes. Daniel is our last presentation, but I wanted to share with you guys how we imagine the bottom. I know this is highways and freeways, but we imagine the first floor, not to have a river, but definitely to have a very open space with a lot of art underneath, and even that is a parking area, we can transform it into a space for entertainment and for exercise. And then the next thing that I wanted to see more examples is that, as we know, these are Frank Lloyd Wright's. We can create templates for concrete, and this is what we want to do with a concrete wall. We want to do a type of masonry that uses digital fabrication and geometry found from nature. And this is a kind of patterns that we can actually create and generate with a CMU. And here are more examples of how we can, like this, we can customize the CMU. So with that, most important, Daniel will be concluding an amazing presentation of not just how to do it on Revit, but what are the concepts and the elements of each of the components that make the building. So Daniel. Daniel was having internet problems before. I'll stop. And then last thing, so we're gonna owe you, Daniel is having technology connection problems, but he was gonna talk about how we got inspired and from a very strong force happening in our city, which is this competition called Low Rise Housing Ideas for Los Angeles. And we're gonna be entering under a fourplex. And it was organized by Mayor's Office and Christopher Hawthorne, the Chief Design Officer for the City of LA. And as we know, there is a big crisis. And these are some of the resources, some of the videos of what the community wants. And that's why we believe that our proposal, as you saw it, it allows for a lot of customization. It also allows for local fabrication for our curtain walls. And the CMU also can have a very own quality of Los Angeles with a lot of the masonry craft. So we are excited about it. The lot was 50 by 150, just like the regulations for the site. And we are very excited to create a template where people can actually utilize and facilitate development that expresses the community's art and design qualities. So this is technological, this is sociological, and this is also green. We're gonna continue working with, of course, we're gonna be doing water collection. That's why we have the CMU. The roof is gonna have solar panels. We're also going to be recycling the water. That's why we have all the water on a curtain wall, and we're gonna use it to irrigate our plants. And then we have a lot of cross ventilation with our stairs and our elevator. We're gonna be studying all the air quality of the space and opening. That's why we also have 25, because it's 10, 5 for circulation, and then 10, and then doing a lot of door opening and window opening so the air can flow. I'm very proud of this team. I know many had to go because they have finals, but with this, it concludes the semester. Congratulations, and I hope this is helpful to catalyze and accelerate more housing in our city of Angels. Thank you.